Hello everyone. So today in this video we are going to discuss the question Umka and Long flight, which is asked in Codeforces Round 863 Div.3. In this question we are actually given a rectangle with whose height is fn and width is f of n plus 1. So let's go into the paint and see. We are actually given a rectangle of height fn and width f of n plus 1. Here fn represents a Fibonacci number, and we are also given that the zeroth Fibonacci number is 1, the first Fibonacci number is also 1, and the second Fibonacci number is 2, so on till then another one is 3, then 5, and so on. Apart from that, we are also given some conditions that we are given an x or y coordinate. Suppose we are given any x coordinate and any y coordinate, and this x and y coordinate must be painted. It means that we are given some conditions, and in the conditions there is a one condition which says that we are given a x coordinate and we are given a y coordinate. Its length is f of n. Its length is f of n plus 1. So actually there are blocks, f of n blocks here. There are f of n plus 1 blocks here, and we said that from, let's say it is 0 comma 0, and we said that the xth coordinate and the x comma y coordinate is marked it is marked means this cell is painted. And we are also said that we have to make actually squares. This is a square of side 1 cross 1. We are also given that we have to make squares such that there are only two such squares who have same side. Suppose this is square of size 2 and this square of size 2. So therefore, in all the squares which we made inside this rectangle, let's say these are the squares which we made inside this rectangle, only at most one pair means only two squares must have same side. No more than two squares must have same side. And the third condition given is the squares which we make. Let's say this square we had make. This square, the side is also Fibonacci number. The size is also Fibonacci number. In this square, the size is Fibonacci number. Suppose this is a square and the size is Fibonacci number. So we have to tell that while painting this section of 1 cross 1, is it possible that and also given that only we consider only two squares having the same side, only two squares, at most two squares, as well as the remaining squares have a Fibonacci number. Is it possible to fill the whole rectangle? This is our question. Let's understand this with the help of an example. So let's take the example number, let's say 565. Let's take the example 565. So what does actually 565 represent? In 565 we are given that fifth, it means f of 5 and f of 6. F of 5 means fifth Fibonacci number. So fifth Fibonacci number and sixth Fibonacci number, we have to make a rectangle using fifth and sixth Fibonacci number. So the first Fibonacci number is 1, second is 1, third is 2, another one is 3, another one is 5, another one is 8, another one is 13, and so on. So we can see that the first Fibonacci number is 1, second is 2, third is 3, fourth Fibonacci number is 5, and fifth Fibonacci number is 8, and sixth Fibonacci number is 13. So we have to make a rectangle of 8 cross 13. So let's make a rectangle of 8 cross 13. So here we will make a rectangle of 8 cross 13. So we had made a grid-like structure of 8 cross 13, and here we are also given 6 cross 5. 6 cross 5 means first, second, third, fourth, fifth, and sixth. The sixth row, and first, second, third, fourth, fifth, and sixth, and first, second, third, fourth, fifth, and sixth, fifth row. that this row is already filled and colored, and this is having size 1 cross 1, and this is already filled and colored with some paint. Now we have to tell whether we will be able to fill the remaining section of the rectangle with the squares such that no more than two squares have the same side, as well as each square will be having a side of Fibonacci number. So let's try to fill this rectangle with the help of square. Let's suppose we start with this is 8 cross 13, this is 8 and this is 13. Let's suppose we first try to make a rectangle of 8 cross 8, square of 8 cross 8. So we can easily be able to see that this completes a rectangle of 8 cross 8. So we fit here a rectangle of 8 cross 8. Now let's suppose try to fill a rectangle of 5 cross 5. So we will be able to see that we will here be able to make a rectangle of 5 cross 5. Let me change the color. We will here make a rectangle of 5 cross 5. Now let's try to make a rectangle of 3 cross 3. So we will be able to see that we will here make a rectangle of 3 cross 3. Now let's try to make a rectangle of 2 cross 2. So we can see that we will here make a rectangle of 2 cross 2. Now let's try to make a rectangle of 1 cross 1. We will see that here we will be able to make a rectangle of 1 cross 1, the smallest section. So we can see that here all the rectangles are having sides as Fibonacci number, as we have used this series of Fibonacci number and used these sides. And first thing, second thing, there are two squares having a length of 1. There are actually two squares having a length of 1. We can see that this square is having length 1, and this square which we are given to us initially is also having length 1. So they 1 cross 1. So there are two squares having same dimensions, and we are also given in the question that at most two squares, at most pair of two squares can have same dimension, can have same side. And we can also see that each length is a Fibonacci number, and the painted cell is given. So yes, here answer is yes, we will be able to make in this question we will be able to cover the rectangle with the squares of side Fibonacci number if it is 565. We can also see that here the answer given to is yes only. In this way we will be able to make in this way we will be able to tell whether the answer is yes or no. So here are two things. First, how we can decide whether we will be able to make yes or we got yes or no. So let's focus on one very important thing here. In the series we can see that the series is 1 1 2 3 5 8 13 and so on. In the above scenario we had used 8 cross 13. Remember one thing, that we have only to use Fibonacci numbers. We have only to use Fibonacci numbers to make the square, first thing. And we can see that we are already given 1 cross 1 square, where 1 cross 1 square is fixed. We are already given where 1 cross 1 square is fixed. So we have 1 given to us. And we also said that we have to use at least or I can say at most two squares having the same side. It means there is a possibility, or I can say the other square which is having the same side will also be 1. It means, or I can say, whenever I was trying to make squares in the rectangle, the important thing is that the two squares having the same side. I am saying that it is necessary that we have to use two squares. It is in the question it is saying that there was at most one pair, but I am saying that it is necessary to have one pair of squares having same side, and those pairs of square having same side have side length equal to 1. Why? Because one length is given in question and one length is remaining with us. And we can also observe that we have to use the Fibonacci numbers only, so to make the square. So it is obvious that we will use these numbers. And here is an important property. We can observe that 8 into 13. which is also the area of the rectangle, is equal to 5 square, which is the sum of 5 square plus 3 square plus 2 square plus 1 square plus 1 square. 8 into 13 is equal to the 5 square plus 3 square plus 2 square plus 1 square plus 1 square. This property, how this property is relevant to us? 8 cross 13 is the area of the rectangle, which we have seen above. We have also seen above, we had made a square of 5, so area is 5 square. We had also made a square. We had also made a square of size 3, so area is 3 square, then 2 square, then 1 square, then 1 square. So we can see that in the formation of rectangle using squares, what we will do is we will use 8, we will use 5, we will use 3, we will use 2, we will use 1, and we will use this one, and not this 13. Why? Because we are given a rectangle of 8 cross 13. We won't be able to make any square of 13 cross 13, but we will be able to make any square of 8 cross 8. So we will start with this 8. We are given f5, which is 8, and f6. That is, we have to make a rectangle between f5 and f6. So we will start with f5, go backward. First we will see whether we will be able to make any square of size 8 or not. If yes, then we will see whether we will be able to make a size of 5 or not, square of 5 or not. Yes, then we will see whether we will be able to make a size square of size 3 or not. If we will not, let's suppose we won't be able to make any square of size 3, so we say that it is impossible to fill out the rectangle with squares, and we will say no. Otherwise we will move to 2 and then 1 and then 1, and we are done with it. So this is the approach. Again, I am saying that that we are given that at most one pair must have same side. I am saying that it is saying at most one pair, but for the formation we have to use exactly one pair having the same sides, and those pairs which are having the same sides are of side length 1 only. And we see that we are in question, we are given f of 5, which is 8, and f6, 8 cross 13. That is, we have to make a rectangle of 8 cross 13. So we will start with f of 5, 8, then move towards 5, then 3, then as you can see also here only, first we had made a rectangle of size 8 cross 8, then we had made a rectangle of size 5 cross 5, then we have made a rectangle of size 3 cross 3, then we try to make a rectangle of size 2 cross 2, then finally we will try to make a rectangle of size 1 cross 1, and as soon as we will be able to make a rectangle of size 1 cross 1, we will be able to understand that yes, we had completed the whole rectangle, and the answer is yes. Suppose this, let's say in the scenario we are the initial painted cell given to us is this, which I am marking right now. Then we can see that we won't be able to make 8 cross 8 square here, or 8 cross 8 square here, or 8 cross 8 square here, or 8 cross square anywhere. We won't be able to make any 8 cross 8 square. So we will say no, that we won't be able to find our answer. Then in that case our answer will be no, as we won't be able to make any 8 cross 8 square. Or I can use another example. Let's say we are given this cell as black cell. So we can make a 8 cross 8 cell here. We can make a 8 cross 8 cell here, which I am marking right now. We can make 8 cross 8 cell here, but we won't be able to make 5 cross 5. Let me clear it out to an extent. These are actually colored section. We will be able to make 8 cross 8 cell, but we won't be able to make 5 cross 5 cell. Here we won't be able to make 5 cross 5 cell. Here we won't be able to make 5 cell anywhere. So we will say that the answer is no in this case also. So let's come back to the code. Back to the code. How we will code this code? How will code out this question? So let me open the code. So what I have done is, first I have, as the number n is less than equal to 44, so as you can see the n is I think less than equal to 44. So first I made a Fibonacci series which is very easily so that I will easily be able to get the nth Fibonacci number. Then what I had done is, See, this is very important to understand. Suppose we are given, that 2 cross 3, 2 and 3, 2 cross 3 is marked with 2 cross 3 is the cell which is initially painted of size 1 cross 1. This is given to us, suppose 2 and 3. So what I had done here is I said height. I here marked it height. Height is Fibonacci of n. We know that the height is Fibonacci of n. Then I will say width. Width I marked it as Fibonacci of n plus 1. Width I will mark it as Fibonacci of n plus 1. Then what I had done is I will pass on height, I will pass on width, I will pass on this height, and I had pass on this width. And next I will pass on is n. N, what does n denotes? Is n denotes that I am dealing with nth Fibonacci number. And another thing I passed is first coordinate, second coordinates, and this Fibonacci vector. I had passed the Fibonacci vector. So let's see what does this x coordinate and y coordinate represents. This section I had write here x coordinate as Fibonacci of n minus x plus 1, and I write y coordinate as y only. So let's see what does this x and y coordinate actually represents. I know that the Fibonacci of n, let's say here it is 5, and let's say here it is extendable forward, so let's say here it is 8. Okay, so it is the height is of length 5 and the width is of length 8. So the Fibonacci, the height is 5 and height is 5, and we are given x to be 2. That is the from the top, this is 2 actually, which I am marking on the grid. This is 2. So 5 minus 2, this means 5 minus 2 is 3 plus 1 4. So if we see from the bottom 1 2 3 4, from the bottom we are representing fourth coordinate. That's why to find out its coordinate from the bottom, considering it to be, let me clear it out to an extent, considering it to be 1, 2 3 4, I want to find its position from the bottom. That's why I have done 5 minus 2 plus 1. So 5 minus 2 is 3 plus 1 is 4, and the y coordinate remains same, that is 1 2 3. Y coordinate remains same. This is y coordinate, that is 3 distance, and this is actually 3 plus 1. So its coordinate from bottom becomes 4 comma 3. Remember, we are saying that this is the x-axis and this is the y-axis. We are saying that this is the x-axis, this is the y-axis. Why this is the x-axis? Because in CP we actually mark this is x-axis and this is y-axis. So I am saying that this height, it is actually at 4. So this is x-axis and it is actually at a distance 3. So first 1 2 and 3. So this is actually y-axis. So 4, so it is at x comma y, or I can say 4 cross 3, so I marked here 4 cross 3. When I'm sending here 4 cross 3, I meant to say that I am passing on the coordinates, considering 1 cross 1 at the bottom. The question I had given xy, that xy represents the xy when we are considering 1 comma 1 at the top. Now I am considering the 1 comma 1 at the bottom. Accordingly I have changed my x and y coordinates. Now let's come to so I made a recursive call answer, and if it is true, then answer is true, else answer is no. So let's check out the recursive call. So this is recursive call, and let's try to understand how we have made this recursive call. So let's come with this grid again. Let's make a grid. Let's say it is f of n. I made it roughly only, and it is f of n plus 1. There are many rows and many columns. I have not made it whole. So and suppose I had got that the 1 cross 1 cell which is painted in this cell. I got to know that from this perspective I had this, and from considering 1 comma 1 at the bottom, I found out the coordinate, this coordinate, and I said that okay, this is the cell actually having this is the cell which is printed initially when considering the bottom. Now what I've done is, if I'm considering all the four sections, first this section, okay, first I'm considering this section, then I'm considering this section, then I'm considering this section. First I'm considering this section, then I'm considering this section, then I'm considering this section, and then I'm considering this section. So these for loops, first for loop is that's why there are four if else condition. If the square which I am going to put does not fit in any of these four sections which I marked, then we will return false here. As you can see, we will return false here, and we will see that we won't be able to fit our square. So first we will see of this section. So what we have done is, we have said Fibonacci of n should be less than or equal to height minus x. What I mean to say is, this length is Fibonacci of n. Wait for a second. This length is height actually. And this is actually my width. And then I'm trying, this is height actually and this is actually my width. Then I'm saying Fibonacci of n. What does here n represents? That I want to fit a square having side length as Fibonacci of n. So this is the height given to me, this is width, and I want to fit a square having side length Fibonacci of n. So this is height, and I know this is x actually. That is the x coordinate. Height minus x, this is the length. You got to know that the height minus x is the length. This, you can see height minus x is here, where I am in the code. You can see I am marking Fibonacci of n is less than or equal to height minus x, and I am marking Fibonacci of n is less than or equal to width. So here you can see I marked. So you can see that this is the height, this is the x, and this is height minus x. If Fibonacci of n is less than or equal to height minus x and Fibonacci of n is less than or equal to width, it means we will be able to fit our rectangle in this section. We will be able to fit our square having a side Fibonacci of n in this section. And from the observations we can say that if we try to fit a square in this section, it will completely cover the width. And it is not necessary that it will completely cover this much height, but it might be possible that it covers this much height, or it covers this much height according to the square which we are trying to make, but it will completely cover the width. Then we will be able to make this completely, make this square. You can consider this as a square. I know this looks like a rectangle, but you can consider this as a square. Then what we have done is, we will call height minus Fibonacci of n. Matlab this we pass as new height. Let me clear it out. This actually we pass as new height. This actually we pass as new width. This actually we pass as new height. This actually we pass as new width. And as we were able to fill out with nth Fibonacci number square, Fibonacci of n side square, now we will going to fill out with n minus 1th Fibonacci of n minus 1th side, Fibonacci of n minus 1th side square. So I have passed here n minus 1. You can see here in the code n minus 1. We can see that the coordinates of this block, which is painted initially, does not change with respect to this, which I am now marking with green color, does not change with respect to this. So we had passed x and y only, and we have passed the Fibonacci array. Similarly we can do for this section. We can see that while doing from the bottom section, which I am marking with yellow right now, we can see that its coordinate will get changed. You will be able to see and analyze with the help of code. Similarly, we will do for this section, and at the end, at the recursive call, and at the end, if n is 0, we will return true. Okay, n is 0, it means we will be able to complete the whole square. We will we will be able to make Fibonacci of n side square, Fibonacci of n minus 1 square side square, Fibonacci of n minus 2 side square. We will be able to make all of them, and at the end we reach n equal to 0 and we will return true. I've discussed the first if case. You can go through the else case, else if case, and else case for the same.